We talked about the population in the East, and we noted that our population in the East started off with what kind of distribution? What's that first distribution look like?
Even.
Yeah, it's totally even. You can call it an even distribution. Some people would say, it's a flat distribution. Yeah. There is no hump. There is no mode. There is no bell curve. There's nothing there. It is flat. And that food source that's pictured there, it's got something for everybody. You've got a little beak, you go after little food. You've got a big beak, you go after big food. You've got a medium beak, you go after medium food. Life is good no matter who you are. The only thing that affects your chances of survival there is just sort of your own talent, how aggressive you are. Like I said, in here we had some really aggressive small-billed clipbirds. Roar! I will get food, I will reproduce. Okay, good. In the wild, that's a really powerful motivator. So going into the second season, it's kind of sheer dumb luck who makes it and who doesn't. But starting in the second season, what begins to happen? Do the birds change? No, but the food sure does. So in that second season, where after the first season we do start to see a skew towards the small end, and it's, again, just because of sort of drive, passion, aggression, skill. But in that second season, when the food comes out, it's different. There's more big food. There's less little food. So the birds that survived the first season were then feeding on that stuff. Okay, so this is the food supply that then gets us into the third season. But still, in the third season, what kind of graph distribution are we seeing now? What do we call a graph that has its mode at one end? Skewed. And this is skewed towards the low end or the high end? Remember the skew, it's skewed towards where the mode is. Is it skewed towards the low end or towards the high end?
Low.
Low. Yeah, we have more small birds than we do medium or large birds. Even though the food sources were getting tougher for those smaller birds. They were aggressive. They were vicious predators of marble fruit or lima beans or whatever. But when we get to the fourth season, what happens to the food supply? Well, it gets really rough on those little birds. It's all marble fruit. The environment has changed. The environment has changed, and this kind of food means how many little birds can actually survive? None. Doesn't matter how good they are, doesn't matter how skilled they are, doesn't matter how aggressive they are. You can't fit your beak around the food. You die. Very sad. Very, very sad. Did those little birds do anything wrong? No. No fault of their own. The environment changed. They didn't have features that fit that environment. So now let's look at what happened in the West. Okay, so starting off in the West, we start off with a totally what kind of distribution? Totally even. Nobody's been favored yet. And the food source that we start off with is also diverse. We have marble fruit, we have big toot fruit, we have little toot fruit. Yeah, there's something for everybody. The only thing that's going to govern whether or not you get enough calories to survive and to reproduce is how good you are. Your skills, your talents, how much you want it. So who survives to the second season is really a matter of skills and talent. And we have 2 smalls, no mediums, and 1 large come into the second season. So basically, those medium bills, they just didn't have it. Maybe they were klutzy. Maybe they dropped their clips. Maybe they got struck by lightning. Maybe they fell off a cliff. Maybe a rock fell on them. You know the saying, stuff happens. sometimes even if you're well suited for the environment, you fall off a cliff or you get hit by a rock or a tree falls on your head. Stuff happens. So what kind of distribution would we call this? How many modes are there? Well, actually, no. There's only one. There's still only one mode. I guess we'd call it weird. It's not really bimodal. It's not. It doesn't have two modes because there's only one large. There are two small. It's just weird. You know. Still not a whole lot of variation there. Well, so coming into the third season with our two small and one large clipbirds, the kind of food that we have is starting to shift. Except on the west side of the island, the shift is towards smaller food. So it's tougher now for those large-billed clipbirds to get enough to eat. Whoops. It's tougher for them to get enough to eat. And sure enough, the numbers out of the second season, when we come into the third season, we still have two small bills. They managed to hold on. They managed to hold on. Of course, the mediums are all gone. They can't reproduce. There are no more mediums. But man, the smalls really grow their numbers. The small, I'm sorry, I have that backwards. Duh. The smalls really grow their numbers. They double their population. Yeah, the large had too. So the large are just hanging on. But the smalls are really thriving. The small-billed clipbirds are absolutely thriving. They're doing wonderfully. So, coming out of that third season, so we had 1, 2, 3. What kind of food are we presented with after that? Because the environment is still changing. It's still shifting. And at the end of that third season in the West, we have nothing but little stuff. It's all small food. So it's nearly impossible for a large bird to get enough calories to survive. I mean, large birds can pick up those little tiny fruits, but large birds need so many more calories to survive and to reproduce. And those little tiny fruits don't have a lot of calories. And so it's just a lot harder for these large birds to get enough calories with that kind of food source. So what do we see in that last season? What do our population numbers look like? Well, we do have one large bird who hangs on. One large bird survives. But the small birds not only continue to, they actually go off the chart here. I didn't make my chart big enough. Their population is huge. So what kind of distributions do we see in the third and fourth season? Very skewed. Strongly skewed. If we continued to play this for more and more seasons, so if we went 5 seasons, and in the West now we've got all popcorn, in the East we've got all marbles, what trends do you think you would see in the population? Yeah, all larges, no smalls. Now, of course, this does not account for the fact that a mutation could pop up. 2 large-beaked parents could have a medium-billed baby. Maybe we get a few mediums over time. But I think over time, or I'm sorry, two small-billed parents could maybe have a medium-billed baby. So we might see some mediums pop up. Whether or not they did well surviving and reproducing, who knows? Who knows? So, which points of natural selection does this demonstrate? Let's review those. Okay, all populations have natural variation. Everybody's a little bit different. Do we have variation among our clipbirds? Yeah, we do. Definitely hits that one. The environment presents challenges for survival and reproduction. Do we see challenges to survival in the clipbirds? Yeah, absolutely. Individuals tend to produce more offspring than will survive. Is that something that we see in this? I think this is the one that's really least represented here. Because we don't have a lot of reproduction. It's not like, okay, every clipbird gets to reproduce every round. You have to kind of have to earn that. You have to get enough calories to do that. So we don't really see that demonstrated. But individuals with a mutation or a feature that has an advantage, that works well for their environment, tend to pass on more of their genes. Who ended up reproducing preferentially? Those that got lucky enough to have the beak that worked in their environment. It wasn't any virtue of theirs. It's kind of sheer dumb luck. Yeah, the environment works well for you. It rewards your adaptation. We can think about this in terms of how brains work. So I want you all to know something. Your brains are all different. You knew that, right? Your brain is different from his brain, is different from her brain, is different from his brain, is different from his brain and her brain and his brain and her brain and her brain and his brain. Now we've got some big broad categories. So, you know, we talk a lot about like attention deficit disorder. And kids, they can't focus. These kids. Well, if it's such a terrible thing, why do we still have people who keep getting born with brain chemistry that seems to not let them focus on just one thing? The school environment, for the most part, rewards somebody who has a brain that allows them to focus on one thing and exclude all the other things going on around them and just do one thing. I want you all to imagine yourselves in a jungle 20,000 years ago. Early human history. So you're in a jungle. Can you all picture this? You got two people. One of them is capable of focusing on just one thing to the exclusion of everything else. And they don't pay attention to anything that's happening around them. They are focused on their task. And their task might be, you know, pounding berries or making spearheads. I don't know what they're doing. They're focused. Any of you feel like you can focus like that? Nothing else distracts you? So here's the other person in this jungle 20,000 years ago. They're making spearheads. Oh, but they're hearing noises. Oh, and they're seeing something moving. And oh, look at that. And they're making spearheads. Oh, but they're looking at this. And oh, they're doing this. And they're doing that. Okay, well, talking about it again. Which one of them gets eaten by a jaguar? Yeah, the one who's not paying attention to anything but what they're doing. So variation in the population is a good thing. Variation in how your brain works is a good thing, too. So we need some of those people who can be able to focus, but you sure better have somebody distractible around them to say, hey, buddy, there's a jaguar behind you. You know, variation is not just something that we should be okay with. It's not just okay that you and I are different. It's awesome. It's the best thing ever. Because if you have a population that's really, really similar, guess what? When the environment changes, they don't have a chance. So we have said that evolution is what? Give me the broad definition that we've been using. Evolution is biological change over time. Yep. Biological change over time. Truly the more modern definition of evolution, it's actually called the modern synthesis. The most modern definition of evolution is in essence this. It is shifting frequencies of genes in a population. So in this population, the genes for what kind of beak are winning out? Small beak. At some point, the genes for large beaks may completely disappear from this population. At some point, if thousands and thousands of years pass, the birds in the east and the birds in the west may cease to be the same species. They may get to a point where other genes are changing. They're isolated from one another. It may come to a point where they can't even reproduce together. They can no longer mate. The modern synthesis of what evolution is: changes in the frequency of genes in a population over time, shifts in traits and especially in genes in a population over time. It's called the modern synthesis because when the theory of natural selection was first put forth by Darwin, we didn't know about genes. We didn't have an understanding of DNA. We didn't have an understanding of chromosomes. We didn't get that stuff. But evolution, the modern synthesis, is that what evolution really is just changes in the frequency of genes in a population over time. Now, those genes might control how big your bill is. They might control if you have 2 legs or 5. They might control if you have a spinal cord or not. Those genes, you have genes that tell your body build a skeleton. An earthworm does not. You have genes that tell your body 2 arms, 2 legs, 1 head. A starfish has a different set of instructions. But changes in particular genes in a population over time is really what evolution is. Okay, your assignment is to go to the sciencechannel.com Charles Darwin game that is linked off PBWorks. Summarize all the tabs, click on Learn About Natural Selection, summarize the tabs, and then play the survival game, screenshot your winning banner. If you don't complete it in class today, it will be homework.